To our third Code and Coffee pop-up here at Richmond Public Library. My name is Wendy. I'm a digital services technician here at the library, but a coder at heart. And so I was really excited to bring the Code and Coffee pop-up here. A couple of housekeeping items before we begin. Washrooms are, fastest way is to exit the library and turn left. Second item, a little bit echoey. We are recording this event tonight and we'll be putting the video up on YouTube. So if any of you have any issues being in the video, please feel free to talk with me. And then also, if you don't mind, people wouldn't mind just squeezing in or perhaps moving forward just a little bit in case there are any late stragglers coming in. Want to make sure that they can grab a seat too. Awesome. So without further ado, I want to introduce you to our first speaker. This is Holly, and she's going to be talking about, can I use that code? Please give her a warm welcome.
Hello. Can y'all, okay. I'm not used to speaking into a mic. Good evening, thank you for coming out. Before we get started, I'm a little bit curious. How many of you are professional software developers? Maybe half, maybe a quarter. How many of you have done programming before? Any sort, even just like one tutorial on the internet? Most of the rest, and I assume the rest of you are here because you want to be a programmer? Or at least somewhat interested in programming? Okay. I'm going to be trying to answer the question of, can I use that code? I'm going to be talking about software licenses when you're an end user as opposed to when you're writing a library and trying to decide what license to set on your own code. So talking about looking at other people's code and checking if you can use it. I'm Holly Becker. I'm a software developer at Sauce Labs. I'm a fan of open source. I'm also one of the co-organizers of PyLadies Vancouver. So if you program in Python, you should come say hi. I like books, and I like birdwatching, and I like board games, aside from programming. You can find me on the internet as Hoesta. And another important thing about me is that I am not a lawyer. I did some research for this presentation, and it was really interesting, and it was very informative, and none of it is legal advice. And because software licenses deal with copyright law, if you have any actual legal concerns, you should definitely talk to a lawyer. Because software licenses are kind of complicated. There are lots of them. They were all written without consideration for the existence of other software licenses. So they have terms that sometimes conflict, or they reference terms from laws in countries that you aren't in, or have unclear definitions of terms and other weird stuff. This is just a summary to get you thinking about software licenses. So first of all, what is a license? Specifically, what is a software license? I'm only going to be talking about software licenses. If you have other creative works, like books or music or art, you should look at the Creative Commons set of licenses. A software license talks about what you can do and what you must do to be able to do that. It allows uses that default copyright doesn't allow you to do, and talks about how you can run and modify and redistribute code when normally under copyright you can't do that. For example, letting you use it in your project. There are lots of different software licenses. Fortunately, they can be broken down into a few different categories with similar rights and obligations, and I'm going to talk about them from most restrictive to least restrictive. So first of all, code that is not licensed. This is, surprisingly, not actually a license. By default, everything is under copyright and can't be used by anyone except the author. But you can ask for permission to use it. But this does mean that if it doesn't have a license, if the author hasn't given you permission, you can't use it. So even if you find code on the internet, or somebody's blog, or some super useful website, if it doesn't have a license on it, it's under copyright, and you can't use it. The next category is closed source or proprietary licenses. Generally, you can't use this code, or you can only use it in a restricted sense, like you can run the code, but you can't modify it, or you can get the binary, but not the source code to modify it. A common example of this is a EULA, where it's like, yes, I agree to whatever you want, I just want to be able to run your code. The Unity game engine is actually kind of fun, where you can use it for free up until you have a certain amount of revenue to make video games, and then Unity's like, no, now you got to pay us. under the terms of the license, which is kind of an interesting business model. The first of the open source categories is copyleft open source licenses. You can use this code, it's open source code, but you have a few fairly significant obligations. You have to keep a copy of the license with the code so that people know it's under that license and available to be used. Additionally, because it's a copyleft license, anything you make with it also has to be licensed copyleft. Copyleft is concerned not just with making software available for other people to use, but keeping it free. It doesn't want open source code used in closed source projects, and the licenses in this category enforce that. Probably the best known, the only well-known example of a copyleft license is the GPL and the closely related AGPL and LGPL, and if that doesn't mean anything to you, I'm going to be talking about them a little bit more detail later. The next open source category is permissive open source licenses. You can use this code. You can kind of do whatever you want with it. There are very few restrictions. Basically, all you have to do is keep a copy of the license with the code so that people know that it's licensed under that particular license. These licenses do other things like disclaim liability or say it's not an endorsement or that kind of stuff, but they're generally not concerned with the derivatives freedom, and you can use them kind of wherever you want. This is a very popular category of license. More than half of the packages on the Python packaging index, which is where you get Python packages from, are licensed under one of these licenses, and there's a bunch of popular licenses in this category, including the MIT, BSD, and Apache licenses. The next category is public domain. You can use this code. There's no restrictions, there's no credit required, there's no license to keep with it. There's actually no copyright on it. This is the biggest difference to the previous licenses, in that it's not actually a license. Nobody has the copyright on it anymore. Licenses work by using copyright to set the terms of the usage, even if the restrictions are very minimal and the terms are very broad. No copyright means there's nobody to set the terms, which means there's no possible license on it. There's also no disclaimer of liability, so you probably don't want to use this for your code if you're considering it for your own project. Although it has been done, the SQLite database is actually public domain. The example licenses in this category try and offer public domain-like rights in jurisdictions that don't have public domain. Again, copyright law is different around the world. And the last category is joke licenses. This is not really a useful category of license. The intent is to be both permissive and funny, but it ends up being really legally problematic. Like, you can use my code if you buy me a beer. So, I buy you a beer, my company buys you a beer, everyone at my company buys you a beer. What if my coworker is using your code and I don't know that? Do I still have to buy you a beer? Do we have to hunt you down and find you to buy you a beer? Is it before or after we... All this confusion about beer makes the lawyers have to go have a beer to make themselves feel better. So generally, you want to avoid these licenses. You probably don't want to use code that's licensed under these because it's a legal headache. And you probably don't want to use these licenses for your own code because it's somebody else's legal headache. I'm going to talk about a couple of specific licenses. Generally, if you're using somebody else's code, it's probably licensed open source. So I'm going to look at a couple of licenses from the permissive open source and copyleft category to set the stage for discussing how they interact. Pay attention, there is a quiz. So starting with the simplest is the MIT license. This is a very simple permissive license, very straightforward. Basically, all you have to do is keep a copy of the license with the code. The license includes the copyright holder information, so there's a little bit of credit happening there as well. It disclaims liability, so you can't sue the copyright holder. It's actually really short. It's only like 170 words, so if you want to try actually reading a software license, this is a good place to start because there's not a lot to it. In Python, it's used by SQL Alchemy and Twisted and 6. I wrote this presentation for a Python conference. The next one is BSD. It's another permissive open source license. Is very similar to the MIT license. It disclaims liability. You have to keep a copy of the license with the source code and with the binary. There's actually two versions of the BSD, the 2 clause and the 3 clause. The 2 clause says all the things I just said. The 3 clause has this other thing about copyright holders don't endorse any derivatives, which is really weird until you realize that BSD stands for Berkeley Software Distribution, and the University of California in Berkeley has a reputation and didn't want people saying that Berkeley endorsed what they did just because they made something using code that was written at Berkeley. It's The 3 class is actually surprisingly quite popular. It's used by NumPy, SciPy, and Pandas, which you might know if you do data science kind of stuff, or Django and Flask if you do web development. The Apache is the third of the big permissive open source licenses. It's longer. It's interesting because it's more explicit about a lot of the things that the previous licenses were implicit about. It explicitly addresses patents and says, grants the rights necessary for patents to run code. Amusingly, it actually includes a clause where if you're involved with a lawsuit over the patents, it revokes your rights to those patents, so you can use them, but only as long as you don't get involved with legal trouble over them, which I thought was kind of funny. Additionally, it actually explicitly licenses contributions back to an Apache project under the Apache license, unless otherwise stated, which I didn't see in any of the other licenses and thought was kind of interesting. Some Python libraries that use it are Request and Selenium, and actually the Android operating system, so the thing in most of your pockets. And last, but definitely not least, is the GPL, or the GNU Public License. This is the best known of the copyleft licenses. It's long, it looks like a software license the way you think it should. It has all the things that you've probably come to expect from a software license. It disclaims liability. You have to keep the license with the code. Version 3 explicitly addresses patents like the Apache license. And all the copyleft stuff. If you distribute a GPL licensed code, or modify and then redistribute the code, you have to make the source code available. So that means if you don't redistribute the code, if you just use it on your own computer or internally within your company, you don't have to do anything special. It's specifically when you give away or when you sell GPL licensed code that you have to make the source code available. This is a little bit more relevant in compiled languages like C and maybe less relevant in Python. Additionally, and this is the one people have usually heard about it for, if you include GPL licensed code in your code base, you have to make the entire code base available under the terms of the GPL. Remember, copyleft licenses want to keep software free. They don't want you making something cool and then not contributing back to the community that it came from. They don't want you taking it and then hiding it away so nobody else can use it. Because of this, it's sometimes called a viral license, because it affects the licensing of the whole program. But the whole program is where the lawyers get involved. What's one program as opposed to 2 programs that talk to each other? And this gets into the technical details of how they interact, where static and dynamic linking are usually considered one program, but calling an API over the web is probably 2 programs. So this is where the lawyers get involved if you want to have a GPL license dependency in your project but don't want to release your code under the GPL itself. There's 2 versions of the GPL as well, version 2 and version 3. I thought there were some really interesting nuances and the differences between the 2, but they're pretty much the same for the purpose of this. The best known example of a GPL licensed project is the Linux kernel. Ansible is also licensed under the GPL. And now the interesting part. Can I use that code? So we're going to discuss if my code is licensed X, can I include a dependency that's licensed Y in the project? And I'm going to ask you to guess the answers to see how good a job I did explaining it. So if my project is closed source, can I include an MIT licensed dependency? Yes, the answer is yes. The MIT has very few restrictions. You just have to keep a copy of the license with your code, which your package manager is probably doing for you, so it's pretty easy. If my code is closed source, can I include a GPL license dependency? Probably not. I mean, there are workarounds to ensure that your project and the GPL project are considered 2 separate code bases. You can build an LGPL layer in between that talks between them in a compatible way, but you're probably going to want to talk to a lawyer over this because it's possible, but it gets kind of complicated. If my code base is licensed under the GPL, can I include an MIT license dependency? Any guesses? Guess of no. Guess of yes. Get all the bases covered. The answer is yes, for the same reasons that an MIT license can be used in a GPL or an MIT license can be used in a closed source project, because the MIT has very few restrictions. Now, interestingly, this is where licenses get a little bit complicated. The combined work of your project plus the dependency is licensed under the GPL because it has to be. That's what the terms of the GPL says. But the dependency is still available under the MIT license. This is where licenses are complicated, but I thought that was interesting. If my code is GPL licensed and my dependency is GPL licensed, can I do that? Yes, it's the same license, so there's no conflict in terms. It's rarely a problem. This one should be very easy. If my code is MIT licensed, can I include an MIT license dependency? Yes, double yes. It's the same license, and the MIT license is very permissive, and you can kind of do whatever you want. This is actually why I wrote this presentation, because I was really curious if I could license my code base MIT and still include a GPL license dependency. Any guesses? Got a thumbs down. Got an I'm not even touching this one. Answer is probably not. For many of the same reasons, it's difficult to include a GPL license dependency in a closed source project. It requires the derivative to be licensed under the terms of the GPL, so I could license my project under the GPL, but if I wanted to retain the MIT license, then I have to do the same sorts of careful separation. It's two projects, not one project, that I'd have to do if it was a closed source project, which is where you start wanting to talk to the lawyers, because it's kind of a pain. So that's it for the common licenses interacting. There's always a couple of questions that get asked when software licenses get discussed. The first one is, how about that code on GitHub? By default, GitHub code falls under unlicensed. Full copyright applies and you can't use it. The copyright holder has given GitHub the right to display it and do things like forking and stuff, but you can't use it in your project because it's not licensed. It's still under full copyright. However, many people have realized this and they put a license in their repository, and that means the code is licensed under whatever the license is, and so you can use it under the terms of that license. But in short, you actually have to check the repository and check the license on it, because by default, you can't use it. And anyone who's done much programming has found Stack Overflow and is like, man, there's a whole bunch of great stuff on here. And the answer is, it's kind of complicated. User contributions are licensed under the Creative Commons Attribution Share Alike license, which is a copyleft license for non-code things. But it's also not clear that the Creative Commons licenses actually apply to code. Usually you get around this by licensing the text on your website under Creative Commons and the code under a permissive license of some sort. But in Stack Overflow's case, the code is not separately licensed. They did discuss licensing the code under an MIT license or a modified MIT license, but community politics happened in part because, on Stack Overflow, you're posting little snippets, which you probably don't care about the licensing of, but there's also Code Review Stack Exchange, where you're posting whole programs and trying to get feedback on them, and you probably don't want to let other people use that. It's a very different use case, so there isn't really a license that fits all the different use cases. It's also complicated because not all snippets of code are big enough to be covered under copyright. To be covered under copyright, it has to be original. It has to have an origin. It has to be something creative. And there's only so many ways to write a for loop in Python. Can you really copyright writing a for loop in Python? So if it's not big enough to have copyright, then it's not big enough to have a license put on it. So this is kind of weird gray area. Overall, it's just a very awkward situation. I'm not going to make a formal recommendation, but I will definitely admit that I use Stack Overflow when I'm programming for reference or for inspiration or troubleshooting for solving a problem. In conclusion, there's a few things I hope you remember from this. First of all, software licenses are fantastic. They let you use other people's code, they let other people use your code, and they enable the whole open source community. Software licenses are also kind of complicated. Permissive open source licenses are really easy and simple and straightforward to use. The GPL takes a strong ethical stance. It doesn't want code to be used without contributing back to the community, and it's a good license if you agree with that ethical stance. But most of all, remember to check the license. Don't assume you can use code just because you found it on the internet. Thank you. I also license these slides under Creative Commons Attribution Share Alike, so if you think licenses are cool and you want to give this talk, you can. You just have to release your changes. Question at the back? I don't. The short answer is MIT works with everything. GPL kind of only plays nice with the GPL. Any other questions?
From a licensing point of view, is there a difference between calling copy library, including the library, or copying and pasting the code into your program?
So the question was, is there a difference between copy and pasting the code into your program versus, I guess, static or dynamically linking it? So MIT doesn't care. For the GPL, if you copy and paste it into your code, then it's definitely the same program. So if what you copied and pasted in was GPL license, your whole code base would be. The GPL is pretty clear that static linking is considered one program. The dynamic linking thing gets into the difference between the GPL and the lesser GNU public license, which I only briefly mentioned, where the GPL says that dynamic linking counts as one program. The lesser GNU public license says dynamic linking is two programs. This is where the lawyers might disagree, though. And for languages that don't do static and dynamic linking, like Python, it's a little bit less clear. It hasn't gone to court yet, so to a certain extent, we don't actually know the answer. We have a lot of people with opinions, but no actual court rulings that I'm aware of. Does that answer your question? I'm happy to discuss this afterwards as well. Nope. I haven't read up on it enough to be able to commentary. Sounds like we're done with questions for right now, so maybe we can discuss this afterwards.
Please give Holly another round of applause. Awesome. And yeah, she'll hopefully be around to answer any questions that come up a little later if you still have some. Awesome. And so next up, we have Mike. Please give him a warm welcome.
Fine. Oh, mic check. All right. Hey, everybody. My name is Michael Yugodaev. I'm the founder of a product called Picture.that, and also run a consulting company. So we do product development called Nano3 Labs. We build mobile, web, and augmented reality apps for companies. And I want to talk to you a bit about ARKit, prototyping the ARKit, and help you get started there. It's a lot less intimidating than what you might think. And it's a lot simpler to understand than a lot of people think when they initially see it. It looks complicated, but it really isn't. So without any further ado, let's just kind of jump right into it. And before we can talk about augmented reality, we kind of need to understand what the difference is between all three things here. So there's augmented reality, we have virtual reality, and we have mixed reality. So augmented reality is about creating the illusion that a virtual object is actually appearing in a real world scene. So we usually do it using either a head display or a phone, and we just superimpose a virtual object onto a camera frame, and that's all there is to it. Virtual reality is starting from scratch and creating a whole environment with virtual objects in there and then tracking your movement throughout that virtual environment. And finally, mixed reality is kind of a term that Microsoft likes to use. And when they use it, they usually imply a much better scene understanding, so understanding what's around you in the environment and having a more immersive experience. So it's kind of an advanced version of augmented reality. And in the future, we kind of predict that all three of them will merge into one. So some people start using the words XR. And a lot of them are actually really, really similar. So if you learn one, a lot of the concepts will transition into kind of all of them. So it's always useful to look at some of the other ones like AR and VR and MR. ARKit was introduced by Apple in June 5th. So an ARKit is it's a library that allows you to augmented reality experiences, and it makes it a lot easier to work with augmented reality. So you get a lot of stuff out of the box for free. Google followed suit and introduced AR Core in August, and it's still in preview. And in September, when iOS 11 finally launched, ARKit became available to 200 million iOS devices, and there's a few apps out there that are really interesting, and you can try them out right now. You can download it on your phone and play around with a lot of those things that I'm talking about today. So how does it work? It's pretty simple, actually. And the way we get this to work is simply by looking at the camera frame. So we open your camera phone. Oh, okay. What's that? Oh. It's this lovely iPhone. So anyway, so we use the camera on the phone, and we take a look at the scene, and we try to find a unique point in the space. So if you look behind me, there's this texture of this young man reading a book, and there's a lot of texture on it. If we just track one point on that picture, and we track it through the different camera frames as we move the camera around the scene, we track it between two different camera frames. We can compute the distance, the displacement of those two frames. And then we compare that to the movement in 3D space of our phone using our inertia measurement unit. So that's accelerometer, the gyroscope, and all those components there that tell us how and where the phone moved relative to itself in space. We do a little bit of math, we triangulate that, and we can compute the distance between us and this thing here. So between us as in the phone and the picture, and then all we need to do is we need to add a virtual object with some perspective in it, and it's really easy from that point forward. So what does it look like? So this is our feature points. So that's the points in space. You'll see them in just 1 second. So it's those yellow points here. Those are all the feature points. So you can see, and we know how far those things are. So we can place virtual objects there. And on a white wall surface, there's no texture. So we can't see anything, and we don't know how far that wall is. And that creates a problem for us. So when we're building Picture.that, which lets you hang pictures on a wall, all of our walls were white. So it presented kind of a unique challenge that we created a simple workaround by using the camera location of the phone and assuming there's a wall. So we pretty much just ask you to pick a picture, go up to a wall, and place that picture on that wall. So when you click on that button there, it just assumes that the wall is where your phone is, and it just lets you put that picture there, and then you can back up and interact with the picture on the walls. And you can put multiple ones there. So it will look like this. You create the one on the left here, the tiger is the real tiger, and the one on the right is the virtual one. You can create collages. You can do fun things like this. I took a bunch of pictures of my whiteboards. I took a picture of my my TV and photoshopped them, and then I hung them on the wall with the app there. Other things you can do is you can use the IKEA Place app. So I used that. So I was using it in real world. I was trying to see if it can reconfigure the office a little bit, and that was really useful for that. So those are just some applications. But the interesting thing is, how do you guys get involved? How do you guys start using this? So the first thing I recommend to everybody is pretty much just take a look at all the different projects out there. That's why I started with some examples for you. So literally go to the App Store, type in AR, and download a bunch of apps and see what's available out there. After you've done that, think of an idea. Just think of something that you can solve, that AR can be beneficial for, and then grab a piece of paper and start drawing some ideas. So this is literally the initial idea for Picture.that, drawn there on the right side. And don't worry about how you're going to implement it. Just draw it out on a piece of paper. From there, you can look at some open source projects. So Apple offers you a really good project with their demo app. And if you go to GitHub and you type ARKit, you'll find this repo called Awesome AR, and you'll find a bunch of open source projects that you can just download it and put on your phone, and you'll have all the source code with the right license, hopefully, and you can use it in your app. Now I'll have to check. And just copy and paste the code. If it's MIT licensed, copy and paste that code. If not, talk to your lawyers. So it's really hard to actually prototype something, like explain to somebody what things will look like without actually prototyping and coding it yourself. So I suggest you just jump into Xcode. It's not that hard. You just click a few buttons there. And I'll give you a sample project in just a second there to do that. And just start coding. Use some really simple 3D shapes and primitives. You don't need to worry about the 3D models themselves. You can find a lot of 3D models later on, but it does take time. You can go to Sketchfab if you need 3D models. It's really good. It's a community of 3D artists, and you can download a lot of stuff for free. So once you're happy with things, you can kind of load up those 3D models, but start with basic 3D shapes and objects. And Photoshop, I kind of found Photoshop to be more useful later on after you prototyped to kind of refine your prototypes. So this one here is actually a prototype. So I did this talk at a conference, and I created this super simple app for one of our clients who was interested in building a watch app, and I wanted to see if it's even useful to show a watch on your wrist. So all I've done there is I loaded a 3D model into Space, and you'll see what I did there in a second. I just put a plane through that watch, and I'll let you put your hand in front of it. So the watch stays in place, and it only rotates when you actually swipe up. So you scroll, and it lets you rotate, and then you can take pictures of that. And the final result looks something like this after you've taken the pictures, and you can send it to somebody. And the idea there was to see if it's even useful. Before I went any further with this project, I wanted to see, does it even make sense to model the watch on your wrist? Maybe there's better ways. Maybe I just leave it in 3D, and it's not useful. So that took me just like a few hours, an afternoon maybe at most. Really, really easy to use. Oh, and I should mention that this is available on GitHub. I'll add a license to it now, so you can actually use it. But you should be able to use it after tonight. If you just go to GitHub, nano3labs/watch demo, you'll be able to download that source code and just do that. So this is what the 3D model looks like. I put a plane through that model there. So that red plane is actually an invisible plane. And all it does, it occludes the back of the watch. So it hides the back of the watch. So it looks like you're wearing the watch. And it doesn't look like your hand is going through that watch. Otherwise, it looks really weird. So really, really simple there. And that's all you really need. And then I just rotate that watch as you swipe. The next decision you'll need to kind of start making as soon as you want to prototype and code this is what 3D engine to use for your scene, for adding your virtual object. So ARKit will give you all the scene understanding, all that stuff, but you'll also need to have a 3D engine to show those 3D objects like the watch. In there, you have three options. You can use SceneKit, you can use Unity, and you can use Unreal. So SceneKit is Apple's own library for doing 3D and physics. Unity is a game engine that was really geared towards games, and now it's used for entertainment and some other purposes, and same with Unreal. So I found those engines to be better off at entertainment aspects. They're not as great if you want to really dig into the nitty-gritty features of the phone, like if you want to start using the dual camera on the phone, you want to start doing something interesting and accessing some of the machine learning capabilities on the phone and all the native stuff that Apple actually gives you. It's harder to use with Unity because you have a layer of indirection that you'll have to introduce. You'll have to write some plugins in order to expose some of those features because they're not available to you in Unity. The other thing with ARKit, Apple really, about SceneKit, that Apple really improved it over iOS 11. So there's a lot of new features to it. Apple really also tends to prefer its own tech if you want to be featured. That's kind of more of down the road for you, but if you do want to be featured, Apple really does like its own tech better. So that's something to consider there. Some other tips there when you're building your apps is to notify the user when the tracking state changes. So things like low light. So when you turn off the lights in the room, it'll start having real problems because unfortunately our phone cameras are not that great in the dark. I'm sure you guys have witnessed that. And it will have real problems trying to recognize those textures and patterns and estimating distance. And what it will look like from a user perspective is things will start to move and it'll start to shift in the scene as you move around things. Just a bad experience. The other thing you'll want to do is you want to test with real people. You want to actually give it to them and see what they do. You also want to test it in different environments. It's not just in your living room that you're using it. You can be using it outside. You can be using it in a dark warehouse. Is it going to be useful in those situations? Does it matter to you as well? Use some gestures a user are already familiar with. So use your phone to actually use the swipe gestures. Use the pinching gestures, as you saw in my demo. We use the pinch gesture there. And use what users will actually do right now with 2D screens. Use it in your AR apps as well. And just be creative as well. Some of the challenges that you'll face is that the tech is still really new. It doesn't work 100% of the times. So it can frustrate certain users. Again, in low light situations, it's going to be really frustrating for them. So you want to let them know to improve the light or let them know that it's not 100% at this time and what they can do to help. The other really interesting thing that's really restrictive from the sort of application that you might want to create is that the origin point of the world, so the 000 point of the world, always starts with where you start the session. And what that means to you is that if you go ahead and you design this beautiful room in 3D with the IKEA app, and the next day you come in and you open the same app, you try to load the same scene, but this time you're actually standing here, all the furniture that you placed will be shifted by this distance. So that's not very useful for you. And this is why there's no saving capabilities on any of the AR apps that I've ever seen because of that reason. So we can only do relative location. We cannot do absolute location. Google has been working on stuff for this. So I'm really hoping that they'll expose that at some point. So far, they haven't. Some other stuff is, again, the drift instability. And the real challenge with VR, AR, MR is that we don't know how to design for those interfaces yet. It's so new that it's hard for us to create something that all users understand, that all users can benefit from, because we don't have apps to copy from yet. We haven't established what works. So that's a real challenge. It's not the technology, it's the design and user education that you'll face as a challenge. And that's why I recommend that you actually ask real people and see what they actually do. And that's pretty much it. So before that, before doing ARKit and doing all this fancy stuff, we're doing really web mostly. Web and mobile a little bit here and there. But I had no background in game development or anything like that. I'm not that interested in game development. I'm interested in apps, and I'm interested in making something useful for real users with AR. So if I can do this, if I can learn 3D programming, and it wasn't that hard, to be very honest with you. It's a lot simpler than you guys think. So you can actually go home on the weekend, open up Xcode, open up that project I gave you, and see what you can do. And if you hit any problems, fire me an email. You can contact me on Twitter as well, and try our app, picture that, and see how you like it. And if you guys have any questions right now, I would love to hear them. Don't be shy. No, I was not detecting the tilt of the arm. So the question is, was I detecting the tilt of my wrist as I was moving it? No, I wasn't detecting the tilt of the wrist. That will require a lot more work and a lot more thinking about it. All I've done is, as soon as you scroll with your finger on the phone, I just rotate it. But it's good enough to give you the idea of the very next feature that I'll implement would be the tracking of the hand. But maybe it's not even useful. Maybe most of the benefit we already gained by just showing it and letting you pretend it's on your hand. So that's kind of the point. Thanks for asking that. That is pretty much the hello world of. So Apple, if you go to Xcode, you click create ARKit project. It will give you a little plane in space, and it will render it away from you. I think it's a 0, 0 point. So you just move back, and you'll see a plane. That's the hello world and that's your starting point. And then you can start replacing it with other models. You can try moving it around. You can try rotating it. You can try responding to some user actions, like tapping on it, things like that. Can you speak up a bit? Yeah, so that's a great question. So the question was, how does ARKit find the origin point of space? Does it do QR codes? No. So ARKit doesn't use markers to track the space. It just uses the phone's sensors to try to understand the relative change in the phone's location relative to the scene, and then it tries to understand how far objects are in the scene so it can actually place them. So it keeps track of, as you move the phone around, it'll just keep the object still, but it's always relative to the phone. So if that's a very good question, because if you get interrupted in that session, so if you get a phone call and you move and you come back, you might lose that tracking, and then things will be shifted again. So that's a big problem. Unfortunately, no. There isn't a very good solution. I've heard a lot of ideas. I've tried doing some research on it. It's something I really wanted to do because I wanted to let you come back and have all the pictures always appear on the same wall. So you can come back the next day if you change your mind, things like that. You can use markers, but markers are a bit of a pain in the ass because the user has to print them. Like, how are they going to get them? I don't even have a printer, so it's not a great solution. You can do some machine learning, and what I wanted to always do is to use sticky notes, but even that's not that interesting. So again, Google has been working on a vision API that lets you localize, so it will recognize things like this armchair here, and in the context, it's this specific one, and that's where it'll localize it based on. So it can actually do that. They've done some demos with it, but it cannot do it right now with AR Core. They're demoing it for Project Tango more. Yes, Google. No. So Google has done that with AR Core. They actually ship a HTML-based browser that kind of does that. The disappointment there, I guess, comes from more, does it matter? That's kind of my question. Is I'm less interested in making it available to everybody rather than making a really good experience there. But yes, there's really good and interesting projects with HTML that kind of let you create AR applications. So it's worthwhile trying. But again, you're not going to be able to access all those fun things, like low-level things that you might be interested to create something more engaging. Yeah, so the question was about lighting and shading and making the scene as realistic as possible. So I assume you're a game developer? Perfect. So there's an ambient light sensor on the phone, and ARKit exposes you to the global value of the ambient light. That is pretty much the state of getting the light. Other than that, you can simulate lights, but you actually don't know necessarily where lights are coming from. So you won't know, for example, that to create a shadow in a specific direction because you don't know where the light source is. So we don't have that yet, but you can kind of fake it. Do we have any more time for questions? All right, you can email me here or you come talk to me right after the talk. Thank you, guys.
Thank you, Mike. Please give our speakers, Holly and Mike, another round of applause. They were awesome tonight. Okay, so that concludes our talks for this evening. We have the space till 9. Technically, the library's open till 9:30. So you're welcome to stick around and mingle, get to know each other a little bit. Or, unfortunately, I know our space is sort of closed off. Our normal Launchpad digital space is kind of closed off for a citizenship ceremony tomorrow. But you're welcome to still sort of wander and check out our 3D printers if you hadn't had a chance to do that yet. Otherwise, I think that's it. Oh, and I guess if you haven't checked out our meetup page yet, meetup.com/RPL Tech Meetup, trying to sort of build a Richmond tech community here at the library with weekly events on Wednesday nights, code and coffee pop-up included. So check it out, join the meetup, and hope to see you guys again soon. Thank you so much for coming.